Hello, my name is Rob Blair, and I will be discussing the quality assurance requirements associated with collecting samples for per and polyfluorinated alkyl substances, or PFAS. The topics that we'll cover today include background information on this class of chemicals, what we know about the occurrence of PFAS in Kentucky's drinking water, sampling and standard operating procedures, preparations and precautions before collecting these samples, the quality assurance requirements, sample collection, holding, and delivery, and potential next phases of monitoring for PFAS in Kentucky. I'll start this slide with the caveat that I am not a chemist, and most everything that I know about PFAS I found at the Interstate Technology Regulatory Council webpage that I've referenced below. However, I will briefly summarize these chemicals to the best of my ability. However, if you need more information, I urge you to check out this website. They have a lot of great resources and fact sheets, especially about the environmental fate of these chemicals. So as you can see from the diagram, PFAS are chain chemicals. The tail is made up of carbon and fluorine atoms that are very tightly bonded. And in fact, this is the strongest bond known to inorganic chemistry. Then they each have a charged head on one end. This creates a molecule that is very thermally stable and resists degradation. For these reasons, it is resistant to water, heat, and oil, which makes it very popular for many applications. Some of the more common applications are waterproofing, stain resistance, non-stick coatings, and AFFF, the firefighting foam. This table comes from our standard operating procedure and lists many, though not all, of the commercial product uses and industrial uses for PFAS. And what you'll notice here is that many of the items listed are common everyday and even household items. So most people come into contact with PFAS on a regular basis. And this is important to remember when we're preparing to collect these samples, that PFAS are all around us, and therefore the potential for cross-contamination is heightened. This map shows the results of our 2019 drinking water study, where we tested finished water at numerous water treatment plants across Kentucky for PFAS. The map does not show actual concentrations. Instead, what it's showing are the number of unique PFAS that were detected at each of the 81 water treatment plants where we collected samples. Those sites that are coded in blue did not have any detections. The ones that are coded in grayscale up to black had anywhere from 1 to 6 detections of PFAS. We ended up with 41 water treatment plants across the state where PFAS were detected. We found that it was more numerous in surface water systems, and that it was also more numerous in those areas that are influenced by urban and industrial land use. This report is available on our webpage if you would like to download it. We do have a standard operating procedure that was just updated in 2020. It includes department level procedures for collecting PFAS samples, and it also includes preparation activities and precautions, as well as considerations of materials and material and gear prohibitions. An important note is that PFAS is everywhere, and our lab can detect these chemicals down into the parts per trillion. And 1 part per trillion is the equivalent of 1 second in 31,710 years. So the potential, again, for cross-contamination is very heightened with these chemicals. As with any other environmental sampling that you've completed, training and preparation will include reviewing the SOP and going through some sample collection training. However, there are several items in our SOP that are much different than any other environmental sampling that we do, and so I wanted to highlight a few of those. The first is our laundry, something that we don't typically have to worry about. However, fabric softeners and dryer sheets are known to contain PFAS. So if you use those in your normal laundry, you will need to wash your field clothes according to the instructions in the SOP. We also need to be aware of prepackaged food and materials and gear that are prohibited, especially waterproof clothing and boots, things that we would normally have in the field with us for any other kind of field work, as well as personal care products such as sunscreen and bug spray, and then snacks that come prepackaged in various types of wrappers. We also need to think about the vehicles that we use. If at all possible, it's best to use a dedicated vehicle that's not in motor pool. That way you know how it's been used and what it's been exposed to. However, regardless of where you get your vehicle, we need to remember that all of them have been treated with interior stain resistance and waterproofing. So we never want to have any of our sampling materials or collected samples in the cabin of a vehicle. We also have concerns about spray on bed liners and pickup trucks. We're not aware of any testing, but we presume that they may have PFAS in them. If you're in a situation where you have to carry materials and samples in the back of a truck that has a spray on bed liner or the back of an SUV that is carpeted, you can always lay down a large trash bag to use as a liner and keep your materials from coming in contact with those. We also like to think about overnight sampling trips. Of course, your chain of custody is the same for these samples as any other, but as much as possible, we tried to avoid holding these samples overnight. As we've already seen, PFAS are widely used and found in numerous products. We do have PFAS-free decon fluids available. However, as much as possible, we try to use disposable supplies, again, to eliminate as much potential for cross-contamination as possible. You should always have dedicated sampling equipment for your PFAS monitoring. The coolers, pumps, tubing, and balers should be dedicated to that project alone during that time. Of course, we can't use any materials that have Teflon because Teflon is non-stick and contains PFAS. There is PFAS-free water available currently through our DEPS laboratory, but it is in fairly short supply. Something else we don't normally have to consider, we do need to take extra precautions at meals. Fast food containers, pizza boxes, any kind of prepackaged foods, all of those will be treated to resist grease and moisture, and therefore they are known to have PFAS in them. I urge everyone, when you're looking through the SOP, to thoroughly review the list of items that have been found to be allowable, prohibited, or yet to be screened. Those that are allowable have been tested and found to be PFAS-free. Those that are prohibited have been tested and found to contain PFAS. And those that are yet to be screened, as the name implies, have not been screened yet. And so we treat them as though they do contain PFAS and avoid using them in the field. Also, notes will go on the chain of custody form only. That's on plain copy paper. We can't use waterproof field notebooks or waterproof paper when we're in the field because that will contain PFAS as well. The DEPS laboratory currently has 2 analytical methods that they can use to test for PFAS. The first is the drinking water analysis, method 537.1. This requires sample collection in a 250 milliliter HDPE container with powdered trisma. It has a very low detection limit at approximately 2 to 3 nanograms per liter or parts per trillion. However, this requires that your water have very low turbidity to be successful. The other method is the non-potable water analysis, SW846, method 8327. These samples are collected in a 15 milliliter HDPE vial and do not require preservative of powdered trisma. It does, however, have a higher detection limit, roughly 20 nanograms per liter or sometimes higher, but we don't have any concerns with turbidity. This was designed for surface water and effluent. And I'll also point out that all of these materials will come directly from the depth laboratory and be prepared for you. And now some specifics about the drinking water method 537.1. All materials will come from the depth laboratory. Each field sample consists of two 250 milliliter HDPE containers, which will be pre-preserved with trisma. So you're essentially always collecting a duplicate sample. Each site requires the collection of one 250 milliliter field blank, and each sample day requires one site to be sampled in triplicate. We also have a trip blank that will ride in each cooler that contains PFAS samples. The requirements for the non-potable water analysis method are very similar. Again, all materials will come from the depth laboratory. The field sample here consists of two 15 milliliter HDPE vials, which will be filled with 5 milliliters of sample. Again, there's always a duplicate, and I'll point out with this, filling this with 5 milliliters of sample can be a little bit tricky, and it is worth getting one of these vials and actually practicing, especially when you've got to submerge it in a stream. Each of these will require one 15 milliliter field blank per site, as well as one site to be sampled in triplicate on each sampling day, and will have its own trip blank for each cooler that is containing PFAS samples. Some common quality assurance requirements for both methods. Once you've collected the samples, they go into a Ziploc bag that will be sealed before being placed into the dedicated cooler on loose ice. We can't use cold packs with these because they're known to have PFAS in them. PFAS samples must all be in a single cooler and no other types of samples in that cooler with those. And you'll see at the bottom, I put PFAS-free ice with several question marks. Our SOP recommends the use of PFAS-free ice. We've also reviewed SOPs for other labs, which make the same recommendation. However, if we go back to the results of our 2019 drinking water study, we know that there are many places that have PFAS in their finished water. And in fact, Frankfurt was one of those sites. So the entire time that we were conducting that study, we knew that our ice had very low levels, but did have PFAS in it. So we were extremely cautious, making sure that everything was sealed. And in many cases, we would go to the lengths of double bagging our samples before putting them in the cooler. And I can tell you that doing that, all of our field blanks and trip blanks came back clean. The sample collection is very similar to any other environmental samples that you've collected before. Again, your sample containers will be prepared and bagged and ready for each site. These will come from the depth laboratory. The first thing you'll do is don nitrile gloves and label directly onto the container with a black Sharpie, no other type of pen. We can't use adhesive labels because, as you can imagine, an adhesive label that's made to be waterproof will definitely contain PFAS. So once you've labeled each of your containers, you'll put on fresh gloves and head to your sampling location. We found through experience from our Division of Waste Management folks who did some of the earliest PFAS monitoring that a team of 3 to collect these samples is optimum. This allows for 2 staff to be in the hot zone, 1 person who is collecting samples and the other person who is placing filled samples back in the bag. And then a 3rd staff member that acts as a scribe to fill out the COC, take notes, keep an eye on things, and then also have a set of gloves ready just in case an extra pair of hands is needed. To start the sample collection, the first thing you'll do is transfer your field blank reagent into the field blank container. If you're sampling from a spigot or pipe, you'll fill the containers accordingly. If you're sampling from a stream, You'll slightly submerge the container before removing the cap so that you avoid the air-water interface, and then recap the container while submerged. Once you've filled that container, it goes back into the Ziploc bag. The security of materials and collected samples is very similar to any other monitoring that you've done. Holding time on these samples is 14 days. However, because of the potential for cross-contamination, we try to deliver samples immediately to the lab and not hold them overnight if we can avoid that. I don't like to leave these in a locked vehicle overnight, again, because of the heightened potential for cross-contamination. And we definitely never leave them in a common area overnight, like we might some samples in a storeroom or a warehouse where we could come back and get them the next morning. We do have access to the DEP's laboratory walk-in cooler after hours. And so if that's something that you need, we can work that out. For our potential next phases of PFAS sampling, I think it's fairly likely that we will see PFAS added into our regular monitoring in the near future. When we do this, it won't be every site, every time, but we will collect and preserve those PFAS samples prior to collecting any other samples, make sure that they end up in their own dedicated cooler and that no other sample types are in there with them. Of course, this is going to present some challenges relative to material and gear that we have to have with us for our other field work that has been prohibited because it contains PFAS. And the second one is that our DEPS lab is currently working on developing a method for fish tissue analysis, and I think we'll see that added in the near future. If you have any questions or would like more information, please don't hesitate to contact me. You can email me or call the phone number, and then also Larry Taylor is available to answer questions about PFAS. Thank you.